So this section will be quite short. It's just about a certain type of identity called sum and difference identities, and I'll show what that means. So there's one for cosine and tangent. There's also one for secant, but we won't, and the other trig functions, but we won't look at those. So some formula for cosine. Now I'll give you the formula. If you want to look at the proof, it's in the book. It's well done. But I won't go into the details of the proof. It's basically a formula for the cosine of the sum of two angles. For example, let's say you want to evaluate the cosine of pi over 2 plus, maybe that's a bad example, but pi over 6 plus pi over 3. Okay, you could use actually that formula, and we're going to do something like that afterwards. So the formula is the following. It's going to be cos of alpha, cos of beta, minus sine of alpha, sine of beta. And so that's the only formula you need to accept, okay? If you want the proof, like I said, is on page 707, okay, if you're interested. What's interesting also is that we can, once we accept this formula, we can get a formula for the cos of the difference of two angles. Okay, and we don't have to go through another proof for that. We can just use, let's say I call this star. Okay, we can use equation star to prove this. How do we do this? We simply have to write the difference as a sum. So I only need to write alpha minus beta as alpha plus minus beta. Okay, and essentially I'm going to replace alpha by alpha in the formula, so then essentially the same thing, but beta by minus beta. So this is going to give me cos of alpha. This is where I'm using the equation star above. Okay, so cos of alpha, cos of, now I'm not going to put beta. Beta is now minus beta, minus sine of alpha, sine of minus beta. So essentially I'm doing some sort of substitution in the formula. And at this point I know that here I know that cos of minus beta is cos of beta. I also know that sine of minus beta is minus sine of beta. So remember, we've seen this in the last video, but actually many times. And this is just due to the fact, again, on the unit circle, if this is beta and this is minus beta, well, these two points here have the same x coordinates, so same cosine, but opposite y values, so opposite sine values. So this is just going to be cos of alpha, cos of beta. So I can just replace cos of minus beta by cos of beta. And then this is going to become minus sine of beta. So now I've got minus minus, so that's going to become plus. So plus sine alpha, sine beta. So basically what I see is that if I start with a minus sign, then it's a plus sign here. If it's a plus sign here, it's a minus sign there. So often we regroup those two equations together. So we've got one here and one here. And we can put those two, let's say this is star star. Okay, so if I do star plus star star, okay, together will give me, okay, that cos of alpha plus or minus beta, okay, is going to be cos alpha, cos beta, okay. Now the thing is that if it's a plus here, it's going to be a minus here. So I'm going to put the minus at the top so that they're lined up. If it's a minus here, it's a plus there. So you see, it's important to line up your plus and minus signs. So actually it's kind of the opposite on the other side. It's minus plus because if you start with a plus, then after that in the formula, it's a minus sign that shows up. and then this is going to be sine alpha, sine beta. So this way we can actually summarize the formula in one single equation, okay, whether it's a difference or a sum. So maybe let's look at an example. Find the exact value of cos of pi over 12. Now, pi over 12, remember, that's not one of our, it's not a nice reference angle. We know the cosine for pi over 6, for pi over 4, for pi over 3, or 0 and pi over 2. But pi over 12 is actually half of pi over 6. It's here, and we haven't learned what the cosine and sine is equal to. We haven't memorized it. But that's okay, because the idea is we're going to rewrite pi over 12 in terms of those angles. So can you see how we can come up with pi over 12 using pi over 3, pi over 4, or pi over 6? Well, the way to do this is essentially we've got 1/12, okay? You can write that as 3 over 12, which is 1/4, minus 2 over 12, which is 1/6. So cos of pi over 12, you can write it as cos of 3 pi over 12 minus 2 pi over 12, okay? And like I said, this is going to be pi over 4, and this is pi over 6. So I can essentially rewrite pi over 12 in terms of one of those three angles for which I know the sine and the cosine. And this is going to be useful because now applying the formula above, I've got the cos of a difference. It's going to be, so here, this is where I'm applying the formula with this being alpha, this being beta. Okay, so it's going to be cos of, if I just recopy the formula, normally you wouldn't have to recopy the formula. I'm doing it so that you can follow better. So it's cos of alpha, cos of beta. And remember, if it's a negative sign here, it's going to be a plus sign there. So plus sine alpha, sine beta. And then I'm going to replace my alpha and my beta by what they are. So this is actually what you could actually do immediately once you get comfortable with using the formula. So the advantage here is that I will know what the cosines of all these angles and sine of all these angles is equal to. And this way I'm going to be able to get the exact value of the cosine at pi over 12. So cos of pi over 4, that's root 2 over 2. Cos of pi over 6, that's root 3 over 2. Sine of pi over 4, root 2 over 2. And sine of pi over 6, that's 1/2. So this is my final answer, but I could regroup everything nicely. So root 2, root 3 is root 6. Root 2 times 1 is root 2. And everything is divided by 2 times 2, 4. And that could be my final answer here. I could also write it by factoring. See, I could factor root 2, so I could write it like that. That would also be a nice way to write down the answer. So both are good here. And I get the exact value at pi over 12. And now since I've got the exact value of pi over 12, I could combine pi over 12 with the other angles to get some other values of sine and cosine for maybe some other angle. So I don't know, pi over 12 plus pi over 6. Okay, that's going to be some other angle, and I could actually technically come up with the cosine there. There's a formula for sine. Okay, so for sine, I want to look maybe first at sine of alpha plus beta. And here's the trick is I want to apply the formula for cos of alpha plus beta. So the trick is to first convert the sine into a cosine. And we can do that because there's a way to do this. Sine of theta is the cos of pi over 2 minus theta. And that's also a formula you don't need to remember really. It follows from the fact that if this is theta, This is cosine sine. And pi over 2 minus theta is actually, so if this is theta, pi over 2 minus theta would be this. Because we would subtract theta from 90 degrees, from pi over 2. So this guy here, this is cos of pi over 2 minus theta. Cos of pi over 2, sine of pi over 2 minus theta. But at the same time, it's also the at this point here, these 2 points, they're linked together by the fact that you can reflect one point across the line y equals x and get the other point. And by doing that, it's going to flip around the coordinates. So by flipping around cos and sine, you would get sine and cos. And then by comparing coordinates, sine has to be equal to the cos of pi over 2 minus theta. Cosine would have to correspond to the sine of pi over 2 minus theta. So this is why I can convert my sine into a cosine. So pi over 2 minus the angle. Careful, we have to put the entire angle into brackets because the minus sign will affect it. And then this is going to be cos of pi over 2 minus theta minus beta. And the way I'm going to do this is I'm going to regroup these together and just this alone. And now it's the cos of a difference of 2 angles. So I'm going to apply my formula for the cos of a difference. And it says that this is cos of this is cos of what? This is, so maybe I'm going to write it here. So cos of alpha minus beta, technically this is going to be equal to cos of alpha, cos of beta, plus, so if it's a minus there, it's a plus here, sine alpha, sine beta. So this is my equation star from before. So this is going to be my new alpha. This is still going to be beta. So everywhere I see alpha, I replace it by pi over 2 minus alpha. So this is going to be cos of pi over 2 minus alpha, cos beta, plus sine of pi over 2 minus alpha, sine beta. And now cos of pi over 2 minus alpha, that's sine of alpha. Okay, cos beta, I keep it the way it is. Sine of pi over 2 minus alpha, that's cos of alpha. And that's sine of beta. And with this, I get this nice formula. Sine of alpha plus beta is equal to the sine of alpha cos of beta plus cos of beta sine cos of alpha sine of beta. So that's the formula. And for sine, if it's a minus, if it's a difference, okay, we could perform the same trick we did before. We're going to get a minus there. So if it's plus on the other side. If it's minus, it's minus. For a cosine of a sum or a difference, it's kind of the opposite. So with that in our new bag of tricks, let's solve another problem. We want to evaluate the sine of 105 degrees. Okay, try to do this on your own. So the goal is to relate 105 degrees to maybe some of the angles we know well, which are what? 0, 30 degrees. 45 degrees, 60 degrees, maybe 90 degrees as well. So how can we get 105 from those numbers? By adding them or maybe subtracting them. Okay, and then try to use the last formula to come up with the exact value of that of sine of 105 degrees. Okay, so 105, you can actually come up with that by adding 45 with 60. So we're going to use the sine of a sum of 2 angles. So this is going to be sine 45 cos 60 plus cos 45 sine 60. And sine of 45 degrees, that's root 2 over 2. Cos of 60, that's 1/2. Cos of 45, that's root 2 over 2. Sine of 60, that's root 3 over 2. And everything is going to be over 4. This is root 2 plus root 6. Actually, it's the same answer as the previous example. Okay. So in the next video, we're going to look at the sum formula for tan.